Good afternoon, all. It is a pleasure to see you all here. I begin today by acknowledging the traditional owners and custodians of the land on which we're meeting. I pay my respects to their elders, past and present, as well as to emerging leaders and the elders from other communities who may be here today. To let everybody know, this meeting is being recorded. My name is Julia Merrill, and I am DAMA Perth Head Branch. I am absolutely honored to host this meeting today. So, ladies and gentlemen, it is my pleasure to introduce our special guest for today's webinar, Professor Asif Gill. With a wealth of experience in data management and software engineering, Professor Gill brings a unique perspective to the topic of digital ecosystem architecture and patterns and tech stack. Professor Gill, I'm sorry, now it starts. Okay. Professor Gill is currently heading up cyber, data and software teams at the University of Technology, Sydney. Now, Asif, you have started off as analyst programmer, and you have moved across various industries, including private sector and public sector. What inspired your transition to academia and your decision to join a university?
Thank you, Julia, and good afternoon, everyone. And also good evening if people are joining from Sydney or Brisbane or Melbourne and Canberra. So yeah, I think this is very, very interesting. So I think curiosity, if I say that one line or one word answer, I was very curious about things and observing things and seeing. And that probably you see in that reflection in my presentation as well today, how I see data and information. And yeah, I was working in the industry, and back in, I think, 2004 or 5, I happened to meet a very, very, very intelligent person, Brian Henderson Sellers. He was a professor, a typical British professor working here. So just he inspired me to join PhD and his center. And center was called Object Technology. Back in the days, object orientation, object data stores were very much in an agile delivery, agile development. So that was brought me into academia. And then I was flipping my hats as well, going back to industry, government, and coming back again. And the people call me pragmatic. So I all the time engage with industry. And since I have set up my lab as well at UTS since 2015, nearly 9 years now, this DL lab or Digital Strategy Architecture and Solutions Lab, we've worked maybe more than 30 plus projects with different industry partners across the private and public sector.
Very cool. And so given your track record with data, before we jump into the presentation, could you please describe your relationship with data in one word?
Oh, well, data in my word. Okay. I would call interactions. Interactions determine data.
Very, very cool. Thank you very much. All right, we have more people here as well. Over to you, Professor.
Thank you very much, Julia, and a pleasure to I'll take it everybody through. I'm very agile adaptive as well, but it's okay to probably ask questions towards the end so we can reflect as well towards the end. And certain slides I will press on, certain slides I will just for information. I'll be happy to share this slide back outside this webinar as well. So I'm just gonna get into it. And let me see, my laser pointer is working. That's fantastic. So I think it's I'm not going to bore you with the definition of information data. I mean, DAMA book provides that. Other books as well. We have seen that for many years. But I'm really going to set the context of knowledge graph-oriented approach to architecture, what I'm going to discuss today as well, as one angle. And that requires that discussion of information and data. I'm using them both together, but please have your own definition. Let's look at the information and data. And I think, Julia, you asked a really interesting question, my relationship with the data, about how I see its interactions. If you're looking at that, I call informational organism like the humans and us. We deal with data. We interact with the information data all the time. Look at a little lunch sometime we eat. And these are the things, right? They're classified, labeled, and they're electromagnetic waves from our eyes coming through, scanning that environment and identifying that information and data based on what signal we receive here. And based on our knowledge or experience behind the scene, it classifies this is a kind of matter, or this energy, or the state of energy is a liquid and or a solid, or it's air, right? It's some kind of, I would say that to put in a perspective. So really, interactions define that the state of information data. And that takes me to the next page, which is a lot of organizations are suffering from too much data. I mean, I started a big data journey probably 2010. And I remember I was working with one of the public sector organizations, mapping out their architecture for the cloud migration. Imagine 2010 or 11, right? And that was the geospatial data. And the data was still shared in really hard drives. They were locked. So the data between different agencies or the different of the council, they would share the data through that. So, but that was the time. And then we went into the big data, all the Hadoop and other thing came into play. But now we are going towards the other side of the spectrum. Do we need that much data? How much data we need? Is it too much to manage? Imagine asking a question to a chief data officer who's accountable for the data privacy, the breaches and the compliance. The amount of information, storage might be cheaper, but your compliance might not be cheaper. And the breach of that would be quite expensive for an organization. So really, I'm looking at data minimization, how we can minimize the data as well. And that's where the architecture journey starts for me. When you say that how much data we needed to manage or identify, we really look at those actors involved in the ecosystem, which I explain a little bit more, and they interact with the information. Those interactions would define the amount of data you needed. If the interaction does not use certain data, it means we are spending money on such kind of data which should not be there, or some other reasons. So really, for me, if I start any architecture project or any data project, I map it out. What are the interactions we are interested in? So that's the takeaway number one, focus on the interactions. And those interactions might be having a government offering some services, like opening a maybe a Centrelink account with the government. That's a service, right? Paying for the license fee, right? That's another service, right? So those are different interactions. And through that interaction involves services and the data. So picking up the really critical services and data, that's the starting point for me when I architect stuff. I do not dive into the data warehouses straight away. Being an architect and going from a software engineering to all the way to the architecture and strategy I have seen all in the last 20 plus years, I will try to make this presentation as simple as possible. But I must acknowledge and make a disclaimer, data is not an easy thing to do, but I just want to make sure that I do not show you complex diagram. I try to make this very simple. So interaction is the key for me when I'm looking at data. But then when we interact, let's say if I'm looking at the screen now, I'm identifying the things like screen, and within the screen, I'm classifying the thing as a webinar, right? So as a human, it's very natural intent for us. We see things, and we try to classify based on what we see and what's the background of what we have. But that's where the ontology role comes into play, the baseline generic concept which we can have in our mind. And then we look at the things, we can start labeling them. And that's where I call generic ontology. And that's my observation, curiosity. When I look at any data information problem, it's my hypothesis based on a lot of your experience, I can use these 9 elements to map any organization's data for the generic data. You can look at organisms. So organisms at a certain place, we all are organisms. At a place online, probably maybe now, right? And a certain date and time. And we are interacting with certain things, right? This presentation is a thing, right? And that's a webinar kind of an event, and the mechanism online, we're setting that. And the state, it is in progress, and then the intuition, whether we are feeling good or bad about this event or not, and then the consequences. Did we get any value of it? So I think this is all about the data. So each interaction might have certain elements from these base ontology, and then you can have a specific ontology. And that's the first step towards defining a enterprise knowledge graph. So the number one, interactions. Number two, we're looking at using a generic ontology or our own lens. You might have your own lens here as well to define the ontology. And then ontology, once defined, you can put into a relational data store or some other way of relation. There are many ways. Knowledge graph has been very popular in the last few years. I've been dealing with knowledge graph for a bit now. It was not popular in the beginning, but then now it's really getting kind of a popularity. Ontology and knowledge graphs are two different things, by the way. Knowledge graph actually represents the ontology, the concept or the domain knowledge of your certain area. So really, knowledge graph is all about if you have those information elements or data elements, they can label with each other, and or they can relate to each other. And then we looking at the property of that particular element and also the relationship and its property as well. So really it's a semantic, adding a semantic to a relationship. We know one-to-one or one-to-many, many-to-many relationship, but within that, we need to define the semantic, and that's where the relationship property comes into play. And then also, we saw the previous slide where there was some juice bottle or burger. So we need to label and class them as well, those relationships and the elements itself as well. So these four things can map it out the whole knowledge graph. And that's where I'm showing around there here how different elements can relate to each other. Their nodes, the circles, and the relationship between them. And then the enterprise knowledge graph or knowledge graph is all about connection-oriented data, where our end goal is how we connect the things together. And the connecting the things together means data sitting in different repositories or data sources. And then might be APIs, how we can map that back to the knowledge graph and link them together. So really the knowledge graph is ontology. You can call that metadata in that sense, the data itself and the data sources. So that really defines a knowledge graph. And then now this approach can be used in a different way, and which I will show you in the rest of the slides, how a knowledge graph can be used to actually in the architecting the complex connected environment and federated environment, which are the data ecosystems. I'm just gonna do maybe a 30-second pause. And is so far everybody is with me on that? If anybody is any kind of comment, otherwise I'll move on. Looks like everybody's okay. I'll just keep going. Fantastic. We have only 1 hour, so I will just give you I would say there's a start of the conversation, not the end of the conversation, this presentation. There's a bit of work I have explained in knowledge graph and this approach in my book published a couple of years ago about architecture as information. And there's a bit of information around there, a bit of blogs I have written about that as well. You guys can Google that as well if you look at that. One more thing I would like to mention that when we look at the knowledge graph, it's a connection-oriented data. Data entities can come from different sources and mapped here, linked together. But important is that there could be 3 types of different kind of graphs. I call that the totally materialized graph, where the metadata data and everything is stored in the graph. Somewhere the virtual graph, where the data stays in the sources, but they're mapping and linking to the sources over mapped into the via metadata in the knowledge graph. And some situation we need a bit of both. Some of the data we need to materialize from the sources, and some of the data we need to virtualize it. So that's really semantic and virtualization come into play within the knowledge graph as well. So we have a bit of a different patterns around there. Now, I just want to make another little bit clarification as well. If we want to go for an enterprise knowledge graph approach, we need to have some kind of platform technology stack or technology. So one of the technology, there are many of them. I have no association with them. I should declare that, but this is one of the technologies I used it, reviewed it, and then other along as well. So Stardog is one of the platform which probably provides how we implement the knowledge graph, the way I explained in the last slide. all the data silos can be mapped, linked to this knowledge graph as a virtual layer or materialized layer or a hybrid layer. And then this layer can be queried by different or used by different apps, AI, BI, or Gen AI tools as well. It means these tools no need to go directly to sources, they actually talk to this one. And so that's the technology over there. Someone may ask a question, what's the difference between a knowledge graph and the graph database? We have been doing graph database as well. Graph database is just storing the data itself in the graph database, like Neo4j and other. You can do the knowledge graph into those databases, graph in databases. But then you have to do a lot of your own work as well, like the virtualization, synchronization of the source to your data graph to make it really a synchronized knowledge graph. So there's a bit of difference between the knowledge graph technology and the graph database technology. So that's pretty much for me setting the tone and how we can use it. I was just going to move the next one. The role of the knowledge graph into the digital data ecosystem. So let me first look at defining it. So in the digital ecosystem view, and that's where I have taken that view or the work in the last 9-10 years, because organization enterprises, they are themselves a system. And that system is actually interacts with the employees. So I'm taking enterprises as an independent entity, and then employees, volunteers, all different actors, regulator, communities, customers, users, suppliers, startups, all they interact with it. So enterprise itself has their own technology, and then the kind of human-centric kind of a business system, facilities, offices, data centers, and the environment in which they operate in. So this is kind of an enterprise, and within that, we are dealing with information and data. It was okay if you go in when we started the journey of handling data in 90s or 80s, but as we came into the cloud and internet world, then the connectivity enabled us to share or flow the data outside the boundary of the single enterprise. And that's where the ecosystem comes into play. Your data might be flowing into your suppliers' data, or the partners you have, or a competitor might be looking at your data out of the paper, and the regulator might be observing the data from a reporting point of view, and so on. So really, the digital ecosystem is all about where the data flows in boundary of outside the boundary of the organization itself. And as an architect, when you're dealing with it, you by default, you need to have that constraint. Can that data be shared? Or can other people's data we can bring into our environment in an easy way? So that's where define the digital ecosystem view. And in the digital ecosystem view, where the data comes into play. So if I go a little bit back of the conceptualization point of view, that you saw on the previous slide, there are different actors involved in that. Employees, volunteers, partners, suppliers, and all those kind of a supply chain or value network. And they interact with each other. And when the interactions happen, they generate this lot of data that needs to connect together. And that network could be federated. And this could be dynamic configuration. New data sources can come up, new partners can come up, other can join or leave. So this makes really life difficult in a way to architect, because you would have no control on who will leave and come. The configuration may evolve and change. It's not static. And that configuration depends on those actors and their interactions. And those all the things generate data. And that's where the knowledge graph comes into play. The knowledge graph can handle those kinds of actors and interaction that generated data around there. And is kind of a connectivity or connection-oriented approach of knowledge graph to capture that data in a network and federated environment, and the configuration can change. So that's where the EKG's use case come into play to actually architect the data within the digital data ecosystem. Let's go a little bit more, this example, more concrete. I mapped up, I worked in my last few years with a lot with the government interacting, because government is really curious about the data. They are the more, I think, They are the more service-centric and data-centric kind of a sector, including the higher education. So really, if you're looking at that, I'm just giving an example of city council, transport, and citizen services, or revenue, and the ATO tax. All those different actors, they interact, and then that's where those information exchanges happen through different transactions and through service use or sharing and all these things. So that's really is a complex web of the data. If you look at this kind of a government data ecosystem, I just blurred this thing just for the sake of not revealing any confidential link, although there was nothing confidential in that, but you can see that different agencies and the sharing data, all right, from one angle to another. Someone is managing, collecting, someone is releasing to another one, they're collecting and they're managing. Someone have purged the same data archive, but other agencies still using. So really even hard to track the life cycle of the data. And I believe data never dies, because one may be purged or archived, but other organization might be still using that data. So that's really tracking that. So that's a complex environment if you're looking at that. And that's where the architecting the data ecosystem is there. It's a network federated environment where different parties are interacting with each other. And the configuration can change depending on the state level. If we talk about the government, state level, local government level, and federal and national level, and even international linking of data sharing. So my question as an architect is that, and the previous CDO as well, can they say with the confidence, do they have control over the data? Do they have observability of the data on that? So that's really the modern architecture is going, which I'm going to share a little bit in the further slides. So how we can have control over data, observability, linking, sharing. And this is all you can see is a network. And that's where the knowledge graph is a way to actually map those links and connections. I'm just going to have a 30-second pause because that's what Mike explained, the ecosystem link with the data ecosystem concept. Julia, are we good to go further? Anybody? People are with me, hopefully.
I think there was one question, and it's going back to beginning of the conversation. Just confirmation that taxonomy. When you say when you say ontology, is that taxonomy? Can you just clarify that? Confirm what the terminology for that?
Sure. So taxonomy is more kind of classification, right? The types of things, where the ontology is more kind of relationship, and also whatever in the taxonomy as well. So ontology has a relationship. So that's a little bit difference between taxonomy and ontology.
Okay, thank you, Robert. Hopefully that answers your question in more detail. We just have a hand up from Malko Zada. Apologies for pronouncing your name wrong. I'm clearly having troubles today.
It's okay. Yeah, I'm happy to take one question at this point because we're nearly midway. Not midway, about 1/3 of that is there. So happy to have a quick question. If people want to say, or they can unmute it themselves, or okay.
So Mal, is that your hand is up? Do you wanna ask a question?
Okay.
All right.
Sorry, that was a mistake.
That was.
I've changed it to lower hand now. Sorry, a mistake. I was trying to see what the question was. You mentioned there was a previous question, and I thought I'd read it. So I must have clicked the raise hand. Sorry again.
No worries. All right. Thank you.
Thank you. Very interesting so far, Professor.
Okay.
Thank you.
Okay, we can keep going. So now what you're seeing on your screen is my reflection of last 10+ years of work. So certain work, I work on data, I work with the DAMA framework, certain place they work with the EDM as well. They're compatible to each other or complementing each other. So environment both work. So what I raised up my learning for the last 10+ years around different projects what is actually happening in the organization when we're looking at the connected architecture or data environment point of view. So I like to make things simple or simplify things which are more actionable. So I divide this, I call a meta framework, which can use DAMA, EDM, mix it up, your own flavor of the stuff as well. In this meta framework, while looking at that, it's interaction centric. What people normally do in the work, there's a steering part where the pulling the things into a certain direction, where the information culture, leadership, support, ISO, strategy, architecture, and governance work together, laws, regulations, standards that come together as well, including ethics and other things. So that's really steering the information handling. And then the other part is about the enabling side, where actually the information is being managed from a different perspective, including access protection, forensics, quality processing, another thing, and information-oriented or data-oriented program projects. And then the last one is the bottom one is actually really where the rubber hits the road is execution. When their information is there, as I showed in the very first slide, actors and interaction, during that they consume or process information. And that's where our systems support them and the modeling visualization story comes into play. So in the execution layer, I call them information operations, information management, and that information kind of steering or the governance, you can put it that way. And then this is a really a meta level, one level above the DAMA. And then you can plug in the DAMA into all those things. For example, if you look in the architecture, you pull the DAMA from here. You can do the governance, you can pull the other things from here, and same other way as well. So really, for me, was to abstracting out what I have been doing in the last 10, 15 years. I have seen this in the organization, steering, enabling, and executing. So that's my mental map at the moment, which I publish in Information Science Journal. And that's, Julia, your point, curiosity. So what I did, I just kind of abstract out what I did. And that's where I share into this journal paper as well. Okay, so that's the meta framework, but I'm gonna look at only the architecture part today. And then I'm gonna use a knowledge graph in the architecture today. As I said, it's a meta framework. It does not offer its own things, but it actually pointed out the things. You can call this as a language or taxonomy, if you want to put it there. If someone asks a question of taxonomy, ontology, could be a taxonomy. It could be, see, as a meta framework. So now moving from architecture part, I'm going to look at the three things: architecture, patterns, and then I'm going to look at the technology stack. And in the end, I will share a little case study. And then we probably have some time for question and reflect on it, what I presented. So architecture point of view, when it comes to the data, if data is not being used by, it means, as is mentioned earlier, or we are not interacting, it's a waste. So our application, architecture application portfolio is a very starting point where the data is being actually used, or they produce the data. At least it's a production house. They're producing the data, consuming the data, and sharing. So that's where the application architecture come into play. And then I just share the point-to-point interactions with the application architecture, with the application, but they could be different, their own patterns, which I'm not going to cover tonight. But really giving you an example, when the applications, they interact with each other, they consume and produce data. And that's where those applications behind the scene used by the end user. So that's a concept I'm trying to link back. And those applications behind the scene put their data in different data systems. And that's where, as an architect, is also important for us. We document what are our data systems catalog, which is very different from a data catalog. People sometimes confuse that. But what systems we have in place, which are supporting, we use and process the data. And a typical organization might have hundreds of applications and maybe few hundreds data systems behind the scenes supporting them. I mean, we have seen that. So where the data architecture fits. So just kind of a conversion. So applications and their architecture might be sitting over there, but the data architecture is all about the application using data system to support the business information needs. And that's where the data systems come into play and data architecture. And I just list few of them, all the way document management to the tables, the data hubs, data lakes, data pipeline, fabric, all the way to the master data system. So So you can see that it's not an easy thing. It's not about modeling something or entity relationship background. It's about looking at what systems we have and how we architect those data systems within the data architecture and what data they store as well. So my focus is tonight is about this part. Maybe some other presentation I can unpack the application part, but I will just go into this one now. So if you're looking at this data part, very traditional data architecture, right? We have been using for many years, right? Very typical applications producing data. We collect those data, either operational data stores or staging area or landing area, we call it. And then data is kind of moved into data warehouse. I call that production system and data warehouse. When they produce the data, they go into the warehouse, very much like the products. We produce the products, they go to data warehouse, packaging, integrating, whatever, and sending off for consumption, which is our really data reporting and analytics. This is very, very typical environment we have been using for a long time. We have a Kimball approach to data integration here, right? We have a Vault model we have here, right? In terms of how we architect, we have Inmon model. We have some other models to do that. But the whole purpose of this was to centralize the data, unify the data from different sources. That's where the data warehouse was. And then there's a master data, metadata, data quality, data governance. You can add more as well. But the key was here, data ingestion, how ingestion from source to here and to here. And then we have ETL, ELT. I mean, this is all traditional what we have been doing there. Replication, duplicate, the copies we create, or we capture the only data changes and the streaming data. So these are the kind of work we have been doing. So this is where we were. And a lot of organizations are still here. But now I'm going to use this as a baseline and explain the pattern, how it has evolved. So we started here, and then we move into the other kind of patterns. So I identified at the very high levels group 6 patterns within that different architecture. We have a very typical application databases, and then we have data warehouse bringing the information unifying from different data sources. We move to data lake or data hubs, thanks to big data technology, Hadoop and they introduced us to this one, right? And then we moved recently to data lakehouse. I mean, I can name some of the you heard of those Databricks and the places or Snowflake, all those technologies coming around into play. So, and then we have data exchange and data satellite. And these are the 2 things were my current last few years focus. This one, data exchange pattern, I would say that I came to know me when I was reflecting things and data sharing. I'm being a part of the ACS Data Sharing Committee. How to share data, how to exchange data. So this is all about storage, but this is about how we exchange outside the organization, because that's the key in the data ecosystem. Being able to share and interact the data or make sure those flows are coming together. And the data satellite pattern, which I shared with you as well. So these are the 2 new things I will mainly focus on. Just a recap for everyone here. When we talk about the application database pattern, there are many ways, but you can see I picked up one application pattern and plugged the data behind the scene. So this could be a typical MVC pattern in an application, and the model of data is mapped around here from a physical database to the object model. We all know object relational model. People worked in databases and stuff, or entity frameworks we have worked in the past. So data application talk to that, a single application. And that could be a relational database, columnar and streaming or NoSQL graph, whatever. But that's where our data architecture journey starts. So that's a very, very simple way of single data source data production systems. Then the data generated by those applications can come into play, integrated into a data warehouse pattern. And we have seen that as well, right? They're mainly for data integration. So data warehouse is all about unifying and integrating. Data could be coming from many systems, and then we try to keep it very, very simple, not to confuse people or baseline as we go. And this has been typically a structured data and having integrating and serving to the external organization or external organizations use it as well. via BIT reporting. But that's what we have been doing for a lot of years. That's the one way. And then we move to data lake pattern, where we introduce a lake environment to it, because we need to deal with the semi-structured and structured data as well, or our data sets, which we can pull over here. Data lakes, sometimes I call data swamps as well, or dirty data lakes, because data lakes gets the data and then who knows who owns what version of what data set, and then bring the governance people, and then their nightmare starts over there. So, but that data lake provided us an opportunity to bring down structured data. But then we're throwing the data sets around there, and then that was really, again, further analytics from and the machine learning and other streaming data analytics, all kind of things happening around here. So just a bit of extension of that. And then data lake can talk to data warehouse as well, as we know. We can have curated data can move into data warehouse, or data warehouse data can move to data lake. Data set could be extracted from here, put it over there, being analyzed by your data science team. So that's a very typical data lake pattern. And then recently the data lake house pattern came into play, which combines the data lake or data warehouse capabilities in a single platform, something like a Databricks or something, or Microsoft's data fabric. I have a different definition of data fabric, no technology specific, but that's where you can see that here. Rather than data warehouse capabilities are doing their own work and data lake their own thing, they combine together so they can cater for the whole kind of data at a one way, one technology to manage that. So that's where we all know that we have got to that far. But that's, again, we're still storing the data, right? We're still like data hoards. We are still doing accumulation mode, right? Okay, this concept called the data exchange pattern. And that's where the data sharing work comes. We store the data, we manage it, but what about the data sharing within the ecosystem? How the hospitals share the data, how the government share the data, or they can share the data. So that's where the sharing data exchange model came into play, or pattern came to play. So an organization have a fully control on their data. They can connect to the data exchange, they can source their internal, external data, they package up, and they can share. But what they share only metadata, but they don't share the data itself. And that's really the key was, so data stays in their destination at their source. And you do not have to duplicate, create the copies like the way you're creating data lake or data lake house or other places. But data lake house, they have a use cases. Still, data warehouse is a use case as well. But this is where when you share the data, I do not send the data straight away, all of it. But what I can do that, I can share the information about my data, which is discoverable. Someone can search, connect to the data exchange, search about my data, based on metadata, and request the data, and then receive the data in a secure file, or the information gateways and pipeline, depending on how you want to access that. Either API you want to use it, or actually data will be given. So really, the magic is around here. And this all metadata information sources can be packaged, wrapper around APIs and services. They can be exposed with that. So that's the information holder, fully control over data. Information audience, they can search about the metadata, but based on their access, they can only search the metadata, but then they can request it. And it's up to the provider what data they're going to share with them. So that's really bringing this knowledge graph. How are we going to store the metadata in the form? So that's where the knowledge graph comes into play, to capture that metadata into enterprise knowledge graph and ontology. And data about the data sources they can capture over there as well. But then data catalog would be the listing of the what data elements would be probably shared. And what are the data different sources would be the data coming from. So in order to build this layer only, we need to have a starting point, a data catalog, and then data catalog item then can map to a enterprise knowledge graph or ontology, and that will probably allow us to share that metadata and allow the data to be shared via this pattern. And of course, in order to have the data exchange being deployed or work together, there's the onboarding, audit and monitoring of since it's not storing any data. So we audit and monitoring the data access transactions, and then the metadata and the sources. and other governance, security, privacy, help, and support comes into play. So this is really a core of the data exchange pattern, where data is being exchanged rather than stored in the middle, unlike traditional data warehouse. And then, of course, in order to manage the exchange, we need an information exchange coordinator, administrator, being able to handle that data and information. Give you a little example of the next slide, how this data exchange could be used. So those data exchanges, I actually describe in this paper around there very detailed. It's freely available, by the way. You don't have to, I would say that purchase it. You just Google it, you'll find it. I explained this pattern, how the emergency information exchange can be set it up. And data could be from different sources, different agencies, emergency departments, they can share the data for a certain purpose. It might be a flood handling event where the data exchange can be set it up in the cloud. And once the flood event is gone, data sharing is not required. The exchange could be dropped down as well. So it could be deployable data exchanges as well. So I explained different patterns, how we can do the data exchanges in the cloud, off cloud, or hybrid, or internal data exchanges and external data exchanges. So that's a starting point for me, how data exchange. Then emergency department can still have their data ambulance there, far there, but they can map and link the data over here. They do not bring the data stored in the central location. So my last pattern, before I go to the little case study and the questions, is that, okay, we are exchanging data between different parties, right? But how we have observability over there, how to get the right data, how are we going to get it real time, no real time, right? Through exchanges, the quality, believability of the data, right? Difficulty with the data governance when we exchange, observe, and then there might be a toxic data, which is not usable at all. Maybe bad quality red dots here. You can see that here, right? As a conceptually. A dark data, which we don't know about it. Like a dark matter in the space. If the electromagnetic waves do not get through the material, that can't detect the data or dark matter. Similarly, the dark data sitting, which we have, but we don't know about it. And the good data, which is probably fit for purpose. And that's the area we need to focus. Our investment should be how we can maximize this and minimize this thing. And that's where the data satellite system, I published this new concept very, very recently. I don't think so there is a solution available for that. There are solutions are happening on this level, but about data satellite system, I haven't seen any solution yet. There are some data governance tools around there as well, but I'm looking at data observability at the state level, national level, or the international level. So data exchange can help us to link the data and help to exchange the data, but how we have control, that's where the data satellite system comes into play. Have a look at this little article. It's a couple of pages, dirty read. I call dirty read in a way, it's very quick and dirty read, and it gives you some ideas around there. Okay, I'm going to jump on to the next one part. So that was, for me, these were the 6 patterns. And the exchange and the satellite system is a new pattern for me. The technology stack, where the data system fits in the all as an architect for us. So I'm just bringing everything together. We look at the applications now, AI, GAI, and the data system, what we all talked in the previous 6 pattern, they can fit around somewhere here. And the platforms, data platforms supporting the data system. I might have a Databricks around here. I might have a Microsoft Data Fabric or some other platforms around here. I might have Azure. So I can overlay the technology stack around here or from different vendors, which I know the intent of my presentation is, and the data infrastructure around here and the data center, the facility part, and the data system dealing with structured, unstructured, and semi-structured data. So that's really bringing things together. I just started a little bit wider, bring it back now here, how we can pull all things there. And the data architect role is to look at this bit, but also go across there, go identity and access management as well, and go downstream as well. At the same time, we look at the PST as well, data privacy, security, and trust as a part of that whole stack. I just going to quickly show a case study, then we have probably 15 minutes for question and answer or something like that. So this is a project I did with one of the organizations. The approach I explained of the data exchange and the pattern number 5. So we had a data catalog and knowledge graph together to use. And here the technology we use Stardome. So the project was, of course, with one of the government organization. I'm not allowed to take the name. That's why I have removed those systems' actual names and put accesses. So these are the internal and external data systems. So we picked up as a part of that, they have a large landscape. But let's look at the one internal system or data source, and then 2 outside the organization data sources, and deploy this exchange model. Rather than storing the data in the middle, how we can have a knowledge graph around here, plus the data catalog, cataloging those data sources here with the knowledge graph and connect with them. So we link and map those sources around here using the knowledge graph, using a Stardome technology. And we use RDF plus graph, which is an RDF graph plus a property graph mix. That's what I call RDF plus or RDF asterisk graph. And we actually have some data, physical data bringing from here, and some we virtualize data. So we use a hybrid approach. And then the Sparkle queries could be executed in this knowledge graph to connect the data and pull the data from here, and then serve upstream on the different applications. And here, when we did this project, the challenge was the customer data architecture we need to do, but customer could be very big. There might be hundreds of data domains. So the important part of that, when you're looking at that data catalog EKG, we identify the domain-driven approach. We identify the one particular domain, few sources to do this architecture and POC of that, and 3 use cases. So we can test it out and link and match. And there was a whole project about customer data linking and matching, because customer data was sitting in different sources, including internal and external, and there was no direct primary key to match or linking. And that probably needs to be worked around here, mapping and linking around here. So that's the project. I was a part of the customer data architecture work we just recently did, and I thought I'd just share with you. We started with a data catalog, EKG, for one domain, particular domain. But within the domain, you might have a different data sources. We picked a few data sources and 3 use cases, which are critical to the business. So that's probably bring together the end of my presentation. I do normally at UTS, we have a lot of architecture courses and stuff happening. But that's pretty much from tonight, I believe, as much as I could simplify for sharing purposes. So that's it from my side, Julia. I'm happy to take questions.
Okay, that is fantastic. Thank you so much, Asif. Very interesting presentation on architecture. I certainly have quite a few questions. For me, that whole idea of data exchange and data satellites as the next stages, in that sort of data architecture, from application databases to data warehouse, and then lake houses and so forth. That's such an interesting concept and extension of that. So that's absolutely fantastic. Now, are there any questions? Mal, your hand is still raised. I haven't been able to put your hand down since the beginning. There is no other questions. There is a couple of questions in. Hold on. We do have a hand raised. I saw it. I'm just going through.
While you're looking, Julia, the question, there are a few questions I think Robert asked. Hopefully, Robert, I answer your ontology and RDF. We use the RDF in the implementation with a bit of a property graph around there. So, yep, that's probably the answer. I hopefully in my case study answer the second question. And absolutely, where does the customer consent fit into your architecture? Absolutely. I explained tonight only the linking and mapping data exchange part of it. But the consent comes into the application. What are the application at the collection point? And also when it comes into data sharing, that's where also comes into the consent as well. Because as a sharer, I have full control on the data because I'm only exposing the metadata. If someone's sending me a request, and then I'm building my consent to approve their request and share the data. And I can also put a lock on that. The data cannot be shared further. But if I share data with Julia, based on my contract with Julia, constant, Julia should not be able to share data further. So how we can add that to the metadata as well. So I explained very detailed in that article on that particular slide, how those kind of different kind of metadata we need to have, including consent and stuff. Okay, I think I answered probably, hopefully, Robert's question.
Yep, definitely. We've got Dimitar with his hand up. Dimitar, the floor is yours.
Can you hear me?
Yes.
Okay. Thank you very much, Asif. I didn't catch the beginning, and I was doing something in parallel because I wasn't prepared. So it's a bit, was like not full attention. Very interesting. I'll have to review again carefully. But I'm just curious because, you know, this architecture which covers all these sort of stages of how data extends, you know, from application, data warehouse, and so on. But most important of all, even though we are learning to address better the non-structured, the structured is the most valuable because that's where the analytics comes from, and you know the general rules come from. So, and for that thing, it's very important actually that we have the proper metadata, because, like, you know, usually with the data scientists, I had some interviews and they will say, what does the data mean? You know, it's not enough to just have the data, but actually to try to understand what was the business purpose. How is that actually shared? And are there any standards, particularly in terms of, you know, we have data governance and ethics, like frameworks, which are not fully defined. How is that? I want to pay sort of attention to my approach to this privacy is that when we put too much emphasis on privacy, we actually disable the main function of the data to get something out of it. Like just one analogy is like you go to a doctor and they ask you, what's the problem? Say, I saw that's my private thing. I cannot tell you much. You know, if you want to find results, you have to disclose the data and then trying to find the patterns when somebody is misusing the data for different purpose. So it's some sort of log of what happens to the data, but we need to make sure that whoever's using the data for the right purpose, they have all the information they need to understand the data. Otherwise, we're just running a risk of misunderstanding and getting wrong results. So what's your approach on that?
Thank you, Mitra. And I think that's a very good question. I think I start with the first one because I think that's the reason of the data meanings, data definition. That's where I started with the ontology as a foundation rather than a knowledge graph first. Because defining that ontology for a certain domain which you identify, let's say I define that customer as a big domain, but within the customer, there were some other subdomains as well. So really defining the ontology and meaning of that business data, which you can say that a logical model of that, the semantic defining ontology. And then knowledge graph is I see as a representation. Then you can represent them as their ontology, their meanings and everything into knowledge graph. So I think that's part, I would say that's where the meaning and the data itself comes into play, rather than just jumping on the knowledge graph technology itself. And the second part was the information privacy, and of course there's a limiting. There's always a trade-off. I can tell my lawyer the right thing, and they can help me out, or I don't tell my lawyer the full story, and they can't help me out. So I think there's a bit of a trade-off, right, with what you said. So I think that's where the data control is what you like to share is going back to the information holder in the exchange model. If you're in control, you can share what you like. But ethics and privacy, another thing, is a very big topic, and I'm happy to come back at a certain stage. I did a bit of actually, I would say that I'm working on that part, a project around copyright, privacy, ethics, especially in the Gen AI area at the moment. Imagining application data is stored in different data sources, and you have a Gen AI on the top layer at the top of the data, and you ask the Gen AI to describe the salary of all the people. if the right access level is not set it up, GenAI can access and telling Julia's salary to me and mine to Julia. But there's a bit of a privacy come into play as well while we're playing with these new toys, GenAI and others. So I would say that I'm happy to come along. I'm working on that information ethics or data ethics and the copyright concerns, which is probably maybe very typical at the moment due to GenAI. And then the last one, structured data you mentioned. Of course, the structured data has a lot of value. And that's where our existing unification of the data in the data warehouse from structure would not fade away. Whether we're using Data Vault, I work with Data Vault and Kimball approaches both, and the very relational in-mon as well. So I think they will stay, but the unstructured data would have its own things as well with the intent, with the development of Gen AI, and it's called generative AI. That's really for unstructured data or content. So I think we're gonna see how it unfolds, Dimitar, in the next few years on unstructured data side.
So thank you very much. I just want to add one more thing. I hope there's time. Was the time? You know, when we build data, you know, the graph database knowledge graph is one example where actually we build relationships, because the traditional what we call relational actually is not too much relational. They are very strict. And when we build new relations, when we find sort of correlations and all that stuff, it's not really properly stored. So we don't go there like the humans store the information and to actually quickly find how this relationship work. And that's why we need either graph, but also how we share this thing, because we have different sort of ways of tools, and how we can share that. We need some sort of standard where we can share that information, and the way how the metadata describes that properly, so everybody understands correctly. So is there anything doing in that domain actually?
Yeah.
Long term?
Absolutely. If you look, and it's sector to sector as well. HL7, as we know, health level records, health records, they're using that standard for data interoperability and data sharing point of view. Then also in Australia, there's the Australian standards, as we know, IT 027, I believe, data standards for interoperability or something. That's work is going on. Absolutely. So data standards would be for different sectors, would be very key in terms of that ontology or interoperability and data sharing. And that makes life, it's like a common language.
All right.
So I agree with you.
I guess we have lots of work actually to
I
improve
agree.
the data sharing capabilities.
Absolutely, I agree with you.
To call it rather than data governance, we should call data enablement.
Absolutely. Now we are on 5 o'clock here in WA, presumably 7 o'clock over in the East. We've got a couple of questions here. Troy, will it be possible to watch a replay? We are recording this session, so we should be able to send out the link as well. And we've got another question, which I feel may be quite lengthy, but nonetheless, Professor, the question is, the satellite approach is very interesting. It will be an interesting ownership chat within the business. Thoughts how to approach it? It came from anonymous attendee.
Absolutely. This is a very new approach, and I'm taking it to different stakeholders to do a POC around there. So I would say that we will inherit the data ownership based on the internal structure they already defined. But the key would be around a data satellite point of view. If this data is an asset owned by a certain group or owned by a role in the organization, if that has a value, we needed to observe that asset and what the asset's health is, regardless of ownership. When we tie the ownership, I normally take the ownership at the asset level rather than the data product level. Data product is very fluid kind of concept in my view. So I wouldn't go there. I would more focus on to the data as an asset, because that's the asset we need to nurture, curate. We need to spend money on to probably acquire, in a way, capture it, and then maintain it. But what we're looking at, observing our asset, and then observing its health and how it is being shared, where it is going. And that's where the data ownership comes into play as well. I will start with a few critical crown jewels, critical data elements. And then I will look at that, how those critical elements are being watched. It's like a data watchdog, data supply system. So happy to have a chat. If you are very, very keen, happy to have a side detailed chat with you, but also look at my that article published on Public Sector Network, which I share and linked in this presentation. And I'm happy to share with Julia, to share with everybody else if they would like to. I'm happy to post on the LinkedIn as well, if that's okay with people to let's see, and then Julia can share and other people from DAMA can share the recording. I hope I answer. It's anonymous. I'm happy to have a chat if somebody want to have a bit of and I'll be happy to brainstorm with them.
Very cool. So that brings us to the end of this session. I don't see any hands up anymore. If everybody's happy with that, we will conclude the session. Thank you very much, Professor. It's been an absolutely interesting and great presentation. Thank you very much. And everybody have a good evening.
Thank you very much.
Thank you. Goodbye.
Goodbye.
Bye.
Bye, everyone.
Thanks. Thanks
Thank
all.
you.
Yeah.
Thank you.
Thank you so much, Lucia.
Thank you, Professor. Bye-bye.